In this video, we're going to practice factoring a few trinomials using the trial and error method. So here I've got y squared minus 10y plus 24, and right off the bat I see that these guys don't have any common factors that I can factor out of all three terms, so I've got to use some other technique. I do see though that it's a quadratic, and I see that it's a trinomial because it has 1, 2, 3 terms. So a good technique to factor these type of guys is to use this method that I mentioned earlier called trial and error. And basically it works like this. You basically know the template of what your answer is going to look like, because something is going to FOIL to be this, assuming that it does factor. And so for instance, the f, the first terms, would have to multiply to y squared. And there's only one way to do that. It would have to be y times y. And then for the last two numbers, I know that there is going to be two things. They're going to multiply to be 24, because that's what you would get for the last, FOIL, with blank times blank would give us 24, but they would also need to add to negative 10. So what I'm going to do is I'm going to make a list of everybody who multiplies to 24, and that's a long list. And so here's something I do, and other instructors will teach this in a slightly different way, but I teach my students to not worry too much about the pluses and minuses until the very end, until they're doing a final check on their pairs that they choose. So when you look at the factors of 24, you'd have 1 and 24, you'd have 2 times 12, you'd have 3 times 8, you'd have 4 times 6, and so that's a lot of options. And so if we also put in the negatives, negative 1 and negative 24 and negative 2 and negative 12, and all those pairs would be added as well. We're not going to add those though. We're just going to leave this as our list. And then we're going to scan this list. We're going to look down this list and ask ourselves if the signs could be anything that we wanted them to be, which ones could even remotely possibly add up to a negative 10. Well, I don't care what the signs are, 1 and 24 can't ever add to negative 10. The 2 and the 12 might, so we might need to check on that one. The 3 and the 8, if they were combined right, still couldn't give you, there's no way they could give you negative 10. But 4 and 6 might, so we have some options here. And so what do we need to do? Well, we need to check each of these, and really there's no preference of which one we start with. We could do either one. So let's start with 2 and 12. And so this is why we call it trial and error. There are some cases that we have to try. So if you tried a 2 and a 12, then the only way to get positive 24 is to have a positive and a positive, but those wouldn't add to negative 10. Or you could have a negative and a negative. So those would multiply to a positive, but they would add to some negative value. But I notice a problem. Negative 12y and negative 2y add to negative 14y, not negative 10. So I don't think that this is going to be it. So we struck out with our first option. So we tried it, but it didn't work. So we're going to go to our next option, the 4 and the 6. So now we're going to try a 4 and a 6. And again, the only way to multiply to a positive would be to have these signs being the same. But to add to a negative would have to be a negative and a negative. Let's double check this real quick. First, outer, inner, last. Y times y would give us y squared. Negative 6y, the outer, and negative 4y, the inner, would give negative 10y. And then negative 4 times negative 6 for the last would be plus 24. And so yes, we did get the polynomial that we wanted. So this is the factored form of that polynomial, and I did it relatively quickly using trial and error. All right, let's close up with this last example here. Same type of deal, x squared minus 5x plus 14. I'm going to go through this one a little bit quicker. I'm going to look for the factors of 14 that could possibly add to 5 or negative 5. So the factors of 14 would be 1 and 14, or 2 and 7, and that's it. 1 and 14 in no way could add to 5 or negative 5, but the 2 and the 7 might. So I think I've got a good read on what I might have for my final answer. So we put parentheses here and here, and then only x times x could give you x squared. So I know that's my leading terms. And then I'm going to try a 2 and a 7. And remember what I said, we're not really concerned with the pluses and minuses until we get to this step. And listen to me carefully. I'm not saying that 2 and 7 are the right answers. I'm saying that they're good candidates to be part of the right answer for this factorization. But now I have to finish the deal. Now I have to close the door. So I need to check out my signs, and I have to ask myself, how could a 2 and a 7 multiply to give me positive 14? Well, it could either be a plus 2 and a plus 7, but you see that won't work because that won't add to a negative 5x. So really my only other option would be minus 2 times minus 7 would give me plus 14. But then let me just double check that real quick. X times x would give me x squared. Minus 9x and minus 2x make, minus 7x. I'm sorry, I misspoke. Minus 7x minus 2x would give me minus 9x. And then negative 2 times negative 7 gives me 14. But this isn't right. Something's off with this. And so that must not be correct. In other words, these signs must not be correct. And so what I need to do is go back and just double check, but I think I've gone through every possibility. The only way to get a minus 5x would be to have minus 7 and plus 2, but then that messes up the plus 14. See, I chose this example on purpose because what we just stumbled across was something called a prime polynomial. Now we're going to talk specifically about these in another video, but I just wanted to show you at least one example that just illustrates the fact that not every polynomial factors. We did not do anything wrong, but this guy has no factorization. We've gone through all the options. And so I do that just because I know this is a common mistake. If we're not going to worry about the signs till the end, then we really do need to worry about them at the end though. And so when you're looking through your list, you can't just slap down a 2 and a 7 and put whatever signs you want. You have to examine this very carefully to make sure that these are in fact going to FOIL to give you what your original polynomial was. So in any case, we're going to talk more about prime polynomials in the next video, but for now, hopefully these examples helped you understand factoring just a little bit better.